Okie dokie, so we're going to be doing a limit definition integral example. For well, the equation we're going to be using is x cubed, because that one's pretty familiar to us. It looks like this S shape, and we're just integrating from 0 to 1. So I want to know the area under the curve from 0 to 1. So to do this, our first step, as always, is to find delta x. So delta x, again, is going to be b minus a. So b is 1. This is a. The 0 is a. The 1 is b. So the 1 minus 0 over n equals delta x. So delta x equals 1 over n. Okay, part 2, we're going to find x of I. So x of I equals, like I said up here, a plus delta x times I. So a is, once again, 0, because it's this bottom one here is 0. So a is 0 plus delta x, which is 1 over n times I. So x of I equals I over n. Cool. So now we need f of x of I. So f of x equals x cubed. So f of x of I equals x of I cubed, which will be I over n cubed. See how I did that? So it's the equation. You plug in x of I into the equation, which is just going to be what x of I is, which is what we just found here, and putting that in the equation. So now we're going to put that in our limit. So the limit as n approaches infinity in the sum of I starting at 1 going to n of f of x of I times delta x. So I know that the limit, so I know this is going to equal the limit as n approaches infinity, the sum in I equals 1, f of x of I, that is I over n cubed, and then delta x is 1 over n. So if I reduce this, I'm going to have I cubed over n to the 4th. Okay? So that's pretty simple. So now what we're going to do is break up this n from our I cubed rule. So our I cubed rule is, if we look back here, n squared times n plus 1 over 4, right there. So we take I cubed, and I'm going to put the n to the 4th over on the outside here. So we're going to take n squared times n plus 1 squared over 4 in the parentheses, right? So n squared, n plus 1 over 4. So now I have this monstrosity of a thing to find the limit as n approaches infinity. So on this top one, I just want to think about the highest degree of n I'm going to get out of this. So out of this binomial, I'm going to get an n squared, and then I'm going to multiply that by an n squared, so that's going to lead me to an n to the 4th. And then in the denominator, out here, I have an n to the 4th as well. So those will cancel out when they go to infinity, leaving, and the n to the 4th will cancel out all the other stuff in the binomial as in the numerator as well, leaving 1 over 4. So this is going to equal 1/4. So the area under this curve from here equals 1/4. So now I want to check that real quick before I run out of time using my graphing calculator here. So I'm going to go y equals x cubed, x math 3, x cubed, graphing. So now it's graphing it. I'm going to second calculate integral, lower limit 0, upper limit 1, and the answer is 0.25. Right there it says 0.25, which is 1/4. So yay, we did it correctly. That's an example of how to do that. Hope that was helpful.